We will learn how to use slope-intercept form to identify the slope and the y-intercept of a line. How to write a linear equation in slope-intercept form. How to write an equation of a line given its slope and y-intercept. How to use the slope and y-intercept to graph a linear equation. How to recognize parallel and perpendicular lines. And how to use slope-intercept form to write an equation to model data. Your project is on the next slide after demonstration. To begin viewing demonstration for project, click play on the bottom of the screen of the next slide. Demonstration for project number 1. Use the slope and y-intercept to graph each equation. Equation number 1. Y equals 3 over 4x and positive 1. Y-intercept is positive 1, or just 1. Here we are. Now we have to show slope, which is positive 3 over 4. Let's use positive over positive. So it will be 1, 2, 3. And 1, 2, 3, 4. Here is location for the second point. And now we can graph. Here is our line. We can attach and extend in both directions. And correct slightly. Okay, done. Equation number 2. Y equals negative 3 over 4x and positive 2. So y-intercept is positive 2 or just 2. Okay, here we are. Now we have to show negative slope, negative 3 over 4. How can we show this? We can show positive 3 over negative 4. 1, 2, 3, positive 3. And 1, 2, 3, 4, we are moving again the current. Now we have second point. And we can graph. First point. And we can extend. Now we have second point. Next, equation number 3. Y equals negative 5 over 4x. How about y-intercept? If you don't see y-intercept is 0. We can always add 0. So here is our first point, 0. Now let's look for slope, negative 5 over 4. So, oh, we are lucky ones because here is location for i's, and here is location for negative 4. Okay, so we can graph now our graph. First point, and here is second point. Oops. Can extend. So next would be number 4. Y equals negative 2 over 3 x and negative 4. Y-intercept is negative 4. Negative 4. And slope is positive 2 over 3. So let's use positive 2. So it will be 1, 2, and 1, 2, positive 3. Here we are. Location for the second point. Now we can graph. Here, first point, second point, and let's extend. Okay, nice. Next, equation number 5. Y equals negative 3. Okay, y equal -3. Aha. And we don't see slope. Slope is 0. So that tells us that this is just horizontal line, because y equal -3, for all of these points on this line, y is -3. Y is -3. Okay. Now next, number 6, x is 2. Okay, so x-intercept is 2, and now for all points which are here, x-coordinate would be 2, x-coordinate would be 2, and slope is undefined because it's vertical line. It's vertical line. Okay. Next, number 7, x is 0. X is 0. So now here is point. X-intercept is 0, and for all points which are on y-axis, x-coordinate is 0. X-coordinate is 0. Vertical line. Oh, it's difficult to show. Okay, I have to move. Almost good. And then y equal 0. This is our practically horizontal line, and it's on x-axis, but it's hard to show. Line on x-axis. Okay, almost perfect. Your slide will be next one, and you have to work manually and then put your work on slideshow and check your work and key. Your project is on the next slide after demonstration. To begin viewing demonstration for project, click play on the bottom of the screen of the next slide. Demonstration for project number 2. Find the equation of each line. Graph number 1. Let's start our analysis. First, look for y-intercept. Y-intercept is 4. First point. Now let's move on our graph looking for second point with clear coordinates. This one. We have second point. Now let's count rise and run. Rise would be 1, 2, 3, and run would be 1, 2, 3, 4. But rise is negative and run is positive. So it will be negative 3/4, and y-intercept is 4. So here we are, equation number 1. Now, graph number 2. What do we have in graph number 2? In graph number 2, we have y-intercept is 4, And if we are moving along this line, we can see that x coordinate is changing. You see, from the smallest to the largest. But y coordinate stay the same. Y coordinate is 4. So now y is 4. Here we are, number 2. Graph number 3. Let's look for graph number 3. What do we have in graph number 3? Here is x-intercept is 2. And y is changing all over, but x-intercept is just 1 point here. And x coordinate for all of this point is just 2. So now equation would be x is 2. This is number 3. Number 4. What do we have in number 4? In number 4, x-intercept is 0 and y is changing all over. Y is changing all over, but x-intercept is 0. Okay, so this is equation number 4. Graph number 5. Graph number 5. What do we have here? X is changing all over, but y-intercept is 0. Y-intercept, y-coordinate for all of these points is 0. This is y. Equation would be number 5. Graph number 6. Look into graph number 6. Y-intercept is -2. And now you can go down to find next point with clear coordinates. Here we are. Okay, now let's calculate rise and run. Rise would be 1, 2, but we are going again the current, so it will be negative. And run would be 1, 2, 3, -3, because we are going again the current. So negative over negative, it will be +2 over 3, and y-intercept is -2. So here we are, equation number 6. Graph number 7. First, look for y-intercept. Y-intercept is 5. And look for next point with clear coordinates. Let's go down. We have more space down. We are moving. It looks like this one. Okay. Now rise and run. Rise would be 1, 2, 3, but we are going again the current. It will be -3. And run would be 1, 2, 3, 4. We are going again the current, so it's negative. Negative over negative, result is positive. Now let's look. Do we have an equation? Yes, this one. It will be 7. And now the last one. Y-intercept is 0. And let's look for slope. We are moving until we will see a nice point. Here we are. Now rise and run. rise. 1, 2, 3, positive 3. And run would be 1, 2, 3, 4. Negative 4 because we are moving against the current. So now let's look. Do we have an equation where y-intercept is 0 and slope is negative 3 over 4? Yes, we do. Here is 8. Now we're done. Your project is on the next slide. Work out your project and then put on slideshow and check your work. Determine whether the lines are parallel. We have equations and graphs. Let's talk about an equation. Each equation in slope-intercept form. So let's highlight each slope. For equation number 1, it will be negative 3 over 4. For equation number 2, it will be negative 3 over 4. For equation number 3, it will be negative 3 over 4. And for equation number 4, it's negative 3 over 4. And remember that slope and parallel line tells us that if we have lines and they have the same slope, they are parallel, or vice versa. Lines are parallel if they have the same slope. So our answer is yes. These 4 equations represent parallel lines. Now let's talk about graphs. If you want to answer the question, lines are parallel or not, you have to identify slope. For the first line, slope is negative 3 over 4. Slope for the second line, and slope is negative 3 over 4. Slope for the third line, and slope is negative 3 over 4. And slope for the fourth line, and slope is negative 3 over 4. Yes, these 4 lines, 4 graphs, they represent parallel lines. Determine whether the lines are perpendicular. We have equations for 2 lines and we have graphs. Let's focus on equations. What do we know about perpendicular lines? If lines are perpendicular, then slope of the second line is supposed to be negative reciprocal of the slope of the first line. So let's work out slope for the first line, which is 4 over 3, and slope for the second line is negative 3 over 4. Now, analyze. First slope 4 over 3, and second supposed to be negative and reciprocal of the first one, so we have to use first one upside down. So second slope is supposed to be negative 3 over 4. Do we have negative 3 over 4? Yes, we do. This is why our answer for these 2 equations. Yes, these 2 equations represent 2 lines and they are perpendicular. Now let's look into graphs. To answer the question, we have to compare slopes. So the first slope would be positive 4 over 3, and then let's plot points and look for the second slope, second point, and tells us that second slope is negative 3 over 4. As you see, now we approve our previous conclusion. These 2 graphs represent perpendicular lines. Let's put the equation 3 times m and 100g equals 1800 in slope-intercept form by solving for g, because here we have g is playing a role of y and m is playing a role of x variable. How can we do this? We have to move term with the m, means like term with x, from the left to the right. As a result, we will have 100g equals 1800 and negative 3m. We are looking for 1g. For that purpose, let's divide it by 100 each piece on both sides and simplify. As a result, we will have 1g equals 18 and negative 3 over 100 times m. We can rewrite this in slope-intercept form, so it will be g equals negative 3 over 100 times m and positive 18. Now, positive 18 is y-intercept or g-intercept, and 3 over 100, this is a slope. In this case, it's negative slope, and slope tells us that for each 100 miles, reduction in gasoline is 3 gallons. This is how to use slope-intercept form.